Hi everyone. Good morning, good evening.
Hi, good evening, sir.
So my voice is clearly audible, right? Actually,
Yeah.
okay. So let's give it a couple of minutes and let's see how many people are joining. Then we'll start, all right?
Okay.
Okay, let's get started. So I'll give a quick intro about myself. Right, my name is Karthik Raja. I'm going to handle the API automation batch for the people, right? So I'm currently a part-time trainer with Veto Automation, but I'm primarily working in a company called Freshworks as a backend engineer now, software development engineer backend. So previously, I was in testing, like manual and automation, API, and all those things. So later, I got interested with development environment, and I primarily develop APIs to consume. We'll talk about a lot more about APIs shortly, but my primary work is to develop the APIs for the UI or browser or web application to consume and handle the backend architecture and to scale the system as well. Right? Freshworks is a SaaS B2B company for people who did not know. Right? Recently went IPO also in the US. So this is a quick intro about myself. I have totally overall for like around 8 years of experience in the industry. So I just wanted to know you people also better. So like how many of you are new to the rate automation and new to the entire API testing? You people can reply in the chat. Okay. So I got only 3 replies so far. And can I also know like how many years of experience do you people possess? Like, can you also post it in the chat? It will be better helpful for me to deliver the content. You can post whether you are new to API or not, and along with the years of experience you have in the industry. If you're a fresher, you can post it as a fresher. Okay. Okay. So 3 years, 5 years, and so on. And I hope many people are new to like automation or API testing and are from the manual testing background, I assume, right? Okay. Anyway, no worries. I just wanted to know the pulse of my audience. We'll start from the basic itself. For people who know the basics, it's well and good. For people who are new, we don't have to worry at all. We'll go from the basics. Right. This demo sessions, the today and tomorrow will be the demo sessions, right? This demo sessions will be also the continuation of this entire batch. It's not like a demo batch is one particular week and the remaining sessions are in the next consequent weeks. It's not like that. The session will continue after the demo itself. It is like a continuation process. Right? Let me start to share my screen. I hope everyone is able to see my screen.
Yes.
Okay. So since it's a first session, right, we'll make this more interactive. If I'll be asking the questions frequently, you don't have to unmute yourself and answer, but like you can just answer in the chat itself. And if you have a really a long question or anything important, maybe you can unmute yourself and talk. I think someone. Right. So what? Let's say we'll start from the basic, right? What is an API? We all know about API is an application program interface. I'm not talking about the abbreviation. In general, what is an API? What's your understanding about an API? So API is a very generic. You can start to post answers in chat. So API is a very generic term, right? Like we call 2-3 things as an API, right? Let's say there are some libraries. We'll talk in the context of Java in the upcoming session going forward, right? So how many of you are familiar with the Java actually? Or like have an idea about programming in languages? Okay. So basically Java is what? Java, we know is a programming language, but if you go a little deeper, Java is what? Java is a collection of classes and methods organized in a package form, right? So in Java, generally we term the entire project as a Java project. And inside Java projects, we organize the classes in the form of packages. And inside packages, we have multiple Java classes. And inside each Java class, we will have fields, constructors, methods, right? So the entire thing, this Java project, which is intended to do a particular purpose, we call that as a library, right? Let's say, what is a library used to read and write an Excel in Java? Any famous library that you might be aware of? There's a library called Apache POI. Anyone aware of this? It's a Java library used to read and write data from the Excel, right? So can we call this Apache POI library as an API? Is this library? This library is ultimately what? It's a collection of Java classes, methods, and packages, right? We can call this, if you're answering correctly. So we can call this as an API. Why this is an API? This is an API because this is a particular piece of code which is intended to deliver a particular result for us by calling its methods, right? So that is the actual definition of an application program interface, right? So why this is an API? This Apache PO is an application intended to read and write in Excel. It's a programming interface, right? It's an interface which is going to deliver some results. What are those results in the context of Apache PO? It's going to read and write the data from the Excel for us, right? So this is called an API, right? So this is a term which is a kind of a definition which we are applying here in the context of a particular Java library. But what about the web? So how a web browser works, right? Let's say I'm going to Google.com. Google homepage loads for us. So how that works actually? I'm actually requesting some information from the servers, and this information is available in somewhere in some part of the world, right? Either in a database or in some other servers, RAM or whatever. That information is served for us via this internet gateway and networks. Can we call this web application as an API? Can you call this as an API? Yes. Why? Because ultimately, I'm sending a request via browser to get the Google home page. But what is going to process this information? The information is going to again be processed by some programming languages or libraries which are sitting in the remote location. That remote location, we call that as a server, right? Right or not? Ultimately, all the requests that are triggered via a web browser or the internet is also going to be processed by some programming language only. Right? And the programming language might contain the packages, libraries, and methods to process all your requests and return the appropriate response. Right or not? It's not like some hardware is responsible for routing your information through the internet, right? But what is actually responsible for reading all this information, returning the right data? Some methods written in some programming language, right? So we can call that also as an API, right? Right or not? Server. We can call that also as an API. So are we able to draw a comparison between this API and this API? This API methods we can directly trigger even in our local, but this API methods will be triggered via some networking paradigm. It's the only difference, right? But the concept is the same. So only we call this is also an API, right? It's a very generic term, but generally some application intended to deliver some purpose, we are accessing those applications via some means, right? So the process or that application which is going to deliver the result is called an API, right? I'm expecting some nice responses in the chat window. Right? It should not be like a one-way communication, at least in the day 0 of the course. So I personally believe in jumping into the basics before exploring anything. So we will start with the basics. We will start with client-server architecture. How many of you have studied or at least have heard about this phenomenon called client-server architecture? Okay. Good. Few people are having a substantial knowledge about that. Anyway, for people who are starting new to this, we'll start, right? So my question is, see, I have a browser here. Okay, I'm hitting some Google internet, Google website. Some data is returned for us, right? As I said previously, some data is requested by this browser, and this request is traveling along your HTTP as a form of HTTP request via your internet data cables through the fiber optic cables or whatever, and it will reach some destination based on the IP address. Right? Every website will resolve to some IP address. Right? So, can we call this browser as a client? In the client-server architecture, what is a client? My first question is, what is a client? Can we call a browser as a client? Yes, browser is a client, right? Why it's a client? Client is something which is going to access the data returned from the server, or which is going to request some data to the server, right? So client is what? Which is going to access data from server, or some tool which is going to request data, or some tool which is going to post data to server. All this information, all these things are possible via browser, right or not? So we can call the browser as a client. Okay. So browser is one example. What can be a second example of a client? What are the other things can be called as a client? Desktop. Indirectly, yes. if you are requesting some information via some desktop application, desktop is a very generic term, right? Desktop is some tool which is sitting on top of your OS, which is powered by your OS to be able to do some operations over your computer hardware. Mobile, yes. In particular, in mobile, what we can call as a client in mobile? Can we call mobile apps as a client? For example, let's say we all use WhatsApp, I guess, WhatsApp, Facebook. All these applications are there, right? Insta. Can we call these applications as client? Yes, right? Again, this as applications has certain UI, but the data is powered from the server. This application is responsible for getting the data from the server or putting the data back to the server. So mobile applications are also technically a client, right? What others can be an example of client? I hope in the context of this curriculum, you might have heard this term called Postman, the tool which we'll be seeing in the upcoming weeks. This is a Postman tool, right? I hope like few people here have explored this. Can we call a Postman tool as a client? Yes, right? Yes is the answer. Why? Why Postman is a client? Again, the same answer, right? Postman is also a tool which is going to do some operations, all the operations, right? We can put some data, we can request some data, whatever. Right? Yes, it can be also called a client. So what else? What other examples can you think of as a client? SOAP UI, yes. SOAP UI is not a part of this course, but still yes. SOAP UI is a very outdated technology, and people are moving away from SOAP to REST. And there is also a concept called GraphQL, which is also kind of unique and useful in many ways. But SOAP is almost 95% of industry moved from SOAP to REST. Actually. Anyway, yes, SOAP UI is a client. Yes, any electronic device that sends and receives data. Yes, technically, yes, totally correct. I agree with you, Satyanand. Great. One more question. There is some library called Rest Assured. I hope you also would have saw that library, right, along the part of this curriculum. That Rest Assured is a library written in Java to perform your API operations, right? Can we call that Rest Assured library, Java code as a client? Can we call this as a client or not? How many of you say yes and no? It's just a Java code. So someone was asking, how can we call this as a client? We can call this as a client because a client is not something you just see through your eyes in the UI and all, right? Client is something. The definition of client is what? A client is something which is going to access the data from the server or request the data or post the data to the server, right? That's the definition of a client. It's not like something we visually see as a UI or nice user interface or whatever, right? So Rest Assured is a library which is capable of doing exactly the same operations, right? Or it can access the data from the server, it can put the data to the server, and it can do all the operation which your browser is doing, your Postman is doing, or SOAP UI, whatever, right? Java code can also do that. So Rest Assured is also a client. One final thing, there is something called curl. How many of you heard this thing called curl? Anyone? Curl request. Yes. So how many of you are from like Windows like, I mean, let me rephrase my question. How many of you have used Linux or Mac kind of environments? Okay. So there is a very useful tool in Linux and Mac kind of environment. We call that as a terminal. Right? Terminal is a kind of an area which is going to access your OS operating system kernels, and you can do almost any operation that you see or do via your UI. In Windows, like let's say for simple applications, if I wanted to talk, you can create a folder, you can navigate through your Windows, and you can just delete files or access files or modify or create files. You can read the content, or you can do a number of things via your UI, right? Everything is possible via this simple black and white screen also. Right? This window is called terminal, and terminal, if you wanted to install some new applications to be able to use via terminal, right? You have to, there are many ways to do that. Generally for Mac kind of environment, I'm using a Mac machine. We have something called Homebrew. Okay, it's a kind of a package manager for your Windows terminal. I'm sorry, Mac terminal, right? It's a package manager. What's a package manager actually? Right? It's going to get some content from the internet, install it for your or put it in your local machine or install it in your local machine, right? Let's say if I wanted to install Java in my computer, or if I wanted to install Node.js or Python in my computer, right? Everything can be done via this terminal window itself, right? And you can access those applications via certain code. For example, I can even run my Java code here. Just if I want to check a Java version, I can just say Java version. It's going to return a Java version for it. Okay. And if I wanted to where is my current directory, I just can say pwd. It's going to print my working directory, right? And if I want to navigate to certain area, I can just use cd change directory command. If I wanted to create a folder, I can use mkdir command. Right? Yeah, many things are possible. Similarly, to install, to trigger your API request via this thing called terminal, right? There's an application that you need to install, but generally it comes pre-installed in your machine in these days. That application is called curl. Okay. CURL. Okay. So if you see the definition, what it is written. So it's a computer software providing a library and command line tool for transferring the data using various network protocols, right? So technically, this definition matches with whatever we call as a client, right? Right or no? So can we call this curl as a client? We'll see how this curl works in the future sessions, but to understand what's a client. Right? So curl is also a client. Right? So there may be many versions or many tools you can call as a client. Yes, put is also a client which is going to access your software. I mean server side or terminal, right? So that we can also call as a client. Yes. Nowadays, since the advent of AWS, right? AWS itself provides a lot of mechanisms to access the server via its applications itself. And also we have more powerful mechanism called teleport to access the servers. And most of the servers, okay, we talk about servers actually. Before going to server section, I just wanted to cover a few more things. So the client is clear, right? Any tool or library which is going to put or get data from the server, we call that as a client, right? And this client is responsible for displaying the information in a nice and presentable manner to our eyes, right? But there has to be some format through which the data communication takes place from a client to a server. Okay, because generally we cannot put some random data and expect the server to understand what we have requested, right or no? Am I making little sense here? So there has to be certain protocols, certain standards that has to be established to be able to communicate with the another computer that is sitting in the remote end of the world, right? Another part of the world. Server is basically what? I just wanted to like get from you people, what is a server? What is your understanding of a server? Because when I started my career, right, I used to think of a server as some kind of very complex mechanism. But to put in a very simple perspective, maybe someone can answer in the chat. What is a server? Gives response to client one who serves circuits. These are very generic. I mean, what the server does, but I'm asking what is a server. Maybe Ravi Kumar came a little close, I guess. Yes. Server is not an API. It's a very vague and like not so right definition of a server. That's a yes. It's a machine actually. Right? So we don't have to server think of a server as a too much like we see in the movies and all those things. Right? Some kind of like kind of this terminal that is running like multiple things that are running here and there. No, it is just a computer. Like how we have our own computers and laptops, right? Server is also just a computer, but it is just sitting in another part of the world, right? And this computer has some special purposes, which are typical characters of a server, right? This computer will also, generally what our computers will have, our computers will have a CPU, a RAM, like a HDD drive, hard drive, right? All the things will be there in the server as well. And also server, some OS will be installed. We'll talk about what kind of OSs might be installed in the server. Some OS will be running on top of this hardware, right? On top of this OS, some application, not just any application, some server application will be running to handle request. Yes, Anand should be almost right. Your definition is almost. It's a physical computer dedicated to run service to serve the needs of other computers. The other computers in this context are clients, right? So server is nothing but a computer which is sitting in another part of the world, which also has a typical CPU, RAM, hard disk, and OS. And on top of the OS, some application will run, and that application is responsible for handling all the requests that is coming from the client and returning the right data to the client. Okay. So Kavita was asking, so server machine or computer has API too. Okay. API too, I'm not getting the question here. So server is where I will put in this perspective. Server is where your API code will be installed, or where your Java libraries or whatever the libraries which are going to handle your request will be present. Right? So see, I am sending some request from my browser. Okay, let's say in this simple example, google.com. Right? So this request is read. Some without internet connection, this will not work, right? Obviously, we have to have an internet connection. Right? So this request is processed somehow, and someone is understanding I'm requesting this Google home page, and it's returning me the right data. But someone is another computer that is sitting in some remote location, which has CPU, ROM hardware, and which also has a OS, and which has a server application, which is very important. This term is very, very important, which has some server application that will be running inside on this top of this OS, right? which will be handling our request. In this example, what is the request that we are trying to trigger here? The request to what? Request to get the home page of Google, right or not? So why this server is important actually? Why can't a browser directly get the data from a database or whatever? Why this server is required? Any answers? First of all, your browser cannot do all the hard working, right? It cannot. It has to trigger the request also, but meanwhile, it has to also understand. Yes, to act as immediate. Yes. So we are requesting some data, right? But someone has to understand that data in the internet and return the right response for us, right? And that intermediator is called as an API, right? And that API is present in this thing called server application. API is written in the thing called server application, which is running on a particular OS, and that OS is sitting on top of some computer which has certain CPU, RAM, and hard drive. Yes. So there are some misconceptions. Yes, generally, Kalivara Prasad, right? Your definition is correct. It's some high-powered machines with more CPU or RAM handle many requests. That's fine. But it's not always about more power. There are many configurations in the server actually. If you want more power computer in as a server, you can get one. If you want to more RAM computer but less computing power, you can also get that configuration. If I want more storage, more RAM but less computing power, you can get the configuration. So configurations are kind of infinite, right? You can just get in any configuration. For example, I just wanted a server computer with a 2.3 gigahertz clocking speed with this processor, let's say Intel processor, or with some 16 GB of RAM, or with 500 GB of hard disk, I can get that computer. Or if I want some 2 terabytes of hard disk with 1 gigahertz of processing power with 4 core CPUs and Radeon CPU, and like 8 GB of RAM, I can get in that configuration also. Okay. Now, in modern world, all these configurations are handled by your cloud computing services, right? What are the examples of a cloud computing services? Yes. AWS. Facebook and Google, no. Facebook and Google are again applications which are sitting on top of the cloud. Okay. Azure, yes. Even Google has some cloud computing services called, yes, GCP. Google Cloud Platform. Right. See, Salesforce is technically not a cloud computing kind of environment, right? Salesforce will come to Salesforce. Yes, IBM Cloud. Yes. Right. So these are the examples of a cloud computing. But my question is, why we need a cloud computer? See, why can't I just have a computer with configurations of my choice and just a single computer alone? Why can't I have? Why have to have this cloud kind of environment? Okay, basically, what is a cloud actually? We say that AWS, Azure, GCP, IBM, these are cloud computing environments. So basically, what is a cloud? Cloud is something in very raw terms. We don't have to go into many fancy terms. But in very raw terms, cloud is what? Yes, cloud computers are nothing but like hundreds and thousands of computers in a single area, right? Which let's say I'm AWS team. I've decided to like host a cloud computing services, right? So I have decided to purchase some, let's say 5,000 computers with certain configurations. Like one computers might have 4 CPUs, one computer might have 8 CPU configuration, one computer might have 8 GB of RAM, another computer might have 16 GB of RAM. Right? You don't have to consider a computer as a single unit like how we have in our laptop or desktop environment, right? You don't have to consider computer like that. Computer is a what? Just pieces of hardware put together, right? And those hardware are what? CPU, RAM, hard disk, your let's say IO ports, right? This is a computer, right? You don't have to think of as a physical unit. These are the hardware parts which are put together and form a computer, right? But what if I have this n number of thousands and 10,000s of this hardware parts put together as a single entity, right, called cloud, and I can virtualize this particular configuration using a software called hypervisor. Okay. So this software is nothing but is going to segregate all the configurations and give it to the user according to his need. Let's say put it in very simple terms. Okay. Let me give some very different example for this. It's kind of getting some like cookie packets and all those things. For example, let's say I have a chocolate cookie and butter cookies, and I have this like 100 packets of chocolate cookies, let's say hundreds and 1,000 packets of butter cookies, and let's say 5,000 packets of vanilla cookies. Right? So if I wanted to distribute all these things, if a user requests some configuration, hey, I just wanted a cookie, right? But he has some different needs. Maybe he needs some 1 chocolate or 5 butter and 10 vanilla, right? You can get to the individual resource from individual cookie and you can just give it as a single plate of cookies, right? Getting my analogy, actually what I'm trying to do here. A user is requesting some configuration. In this example, the cookie is your CPU, RAM, and hard disk, right? So let's say I'm purchasing some 5,000 computers, 5,000 CPUs, and some 5,000 physical RAMs and 5,000 hard disks with some certain data. So together, let's say each computers will have certain cores, and all these 5,000 CPUs will have a total of let's assume 30,000 cores. Possible, right? You're getting my analogy here. I'm purchasing some n number of computers. Together, it might have some 30,000 cores of computing power, right or not? And let's say I'm purchasing some 1,000 RAM. Together, the total RAM capacity might be like, let's say, 10,000 terabytes of RAM. Okay. And let's say I'm having a hard disk. Hard disk like some 5 million GB of like storage I'm having, right? So together I'm having this much capacity with all the computers that I have purchased. But a person who is going to need a server doesn't have to have all these computing power, right? So there is a software which is going to handle all these configuration requests that is coming. That software is called hypervisor, right? This hypervisor is going to sit on top of this virtual or a physical machine, and it's going to split this computing resource based on your need. For example, a person one is coming. Okay, he says, I need a server with certain configurations. He says, I need a server with 8 CPU cores and let's say 16 GB of RAM and let's say 500 GB hard disk. This is a very simple configuration which we all might use, right or not? So what this hypervisor does, it reads this request and it is going to get this 8 CPUs and 16 GB of RAM and 500 GB of hard disk from the total storage that is available, and it's going to give this particular person one that configuration, that power, right? Yes. Is this hypervisor same as virtual VMware? Yes, it is same, right? In general term, we call this as a hypervisor, but different companies have different names for this. Okay? It is the same. So the software is responsible for like analyzing the request and getting the physical raw data and convert into a virtual data. This CPU is called virtual CPU, right? And virtual RAM and virtual hard disk. Right? I don't know. And person 2 might request some other configuration. Again, hypervisor is responsible for splitting this data and giving this computing power to the particular person. So can we understand why we need a cloud computing kind of environment? It's going to better manage all the physical resources and split according to the needs, right? For example, person 1 might not need this configuration after 2 to 3 days. This configuration might be reassigned to some other person, right, who might need this, right? So we can save the cost, optimize the performance, and we can optimize the physical resources that are available using cloud computing. Okay. So AWS, if you go to the server factories, it's nothing but hundreds and thousands of computers that are physically connected together and virtually splitted through this OS call or some software called hypervisor. Okay. Yes, use as per need. Okay. So now we have a understanding of what is a cloud computing and generally what is a server, right? Server is nothing but a physical computer that is sitting in some other location. Okay? Now this physical computer will have certain OS to run on top of it, right or not? Computer with just CPU and RAM is useless. It has to need some OS to perform some operation and to better make use of the computing power. Right? So any idea of what are the OSs that can be run on a server? So primarily Linux based OS. Correct. So one of the famous Linux based OS is Red Hat Linux distribution. Right? And this, I mean, I think hope you are aware of what's the Linux based distros and all. So there is something called CentOS. How many of you are aware of this OS called CentOS? Linux is an open source distribution. In a real world, most of the companies which are going to use these servers, okay, was using this OS called CentOS. Okay, previously, before the Linux became so much popular, there were Windows Server, but Windows Server has some UI. You can log into the UI and set up the server, but it was too much clunky. People did not prefer a UI in the server actually. Right? People doesn't have to have a UI like this to like go and navigate certain folders and create certain files like this. Maybe right click and create a folder and all those things. We don't have to have the UI kind of environment in a OS to access. As I said previously, this terminal is more than capable of doing anything, whatever your UI does, right? Why the CentOS was very, very popular? Because this Red Hat Linux was there, right? Red Hat Linux was a paid like application, paid Linux distribution. Why it's paid? Because Linux in general term is free, but if you have any security update or if you wanted to have some latest software applications installed in your OS, Red Hat will provide support immediately for you. For the support, you are paying Red Hat. Right? So this CentOS is typically very, very secure OS and very, very bug-free OS, primarily because CentOS is a downstream OS to Red Hat. Okay, when I say downstream OS, so what is a stable release is what? You have your mobile phones. some applications will be coming, OS updates will be coming in iOS or Android or whatever. Latest version is Android 12, right? And iOS 15.45, whatever, I guess, right? So latest version you will download and install in your computer, in your mobile and all, right? But that version is called a stable version, stable release, right or not? Because the unstable release will be either in a testing phase or the beta customers. We know as a testing people, right? Only stable release will be released to the end user, right? That stable release, this Red Hat Linux had, and since CentOS is a downstream of this Red Hat, it was more stable than Red Hat itself. So whatever stable release comes to Red Hat Linux, that will come to CentOS. But what's the difference between CentOS? Red Hat Linux is paid version, but CentOS is totally free, which is as good as Red Hat Linux. Right? So people were going for CentOS, and you might ask why this kind of arrangement. This kind of arrangement is there because Linux is open source. You cannot, any one person cannot go ahead and say, I'm the owner of Linux, right? So what this people did, Linux did, they realized since CentOS is more popular than our own Linux because it's much stable than our own OS, because we are only giving that OS to them, right? They removed the CentOS as a downstream OS, right? And made this as an upstream OS. Upstream OS is because this Linux itself, the Red Hat Linux itself will have some another OS distribution which is upstream to it, a less stable version than a Linux. So CentOS, Linux, Red Hat made this CentOS as a less stable version of the Linux distro of its own, right? So the creators of the CentOS thought, and they made one more OS called Rocky. You can read about this Rocky Linux. Okay, they made this one more Linux distribution called Rocky Linux, which is going to be a downstream like CentOS, downstream OS from the Red Hat. So only CentOS and Rocky Linux are kind of very, very popular now. And people who are having these servers will run these kind of OSs in their computers, not your typical Windows or Mac kind of. Okay, upstream and downstream. As I was talking, right? Typically, what's an upstream and downstream? If I am using some application, data is flowing from any other application to my application, that application is upstream for us. If we are giving data to some other application, that application is a downstream for us, right? CentOS was downstream to Red Hat Linux because Red Hat Linux stable version is given to the CentOS, right? Now that stable version is given to Rocky Linux. Okay. Typically, if you wanted to use other OSs also, it's technically possible, right? Even you can use Mac OS or whatever you wanted to use. Even you can use Windows as a server. But generally,
sorry to interrupt you. I'm sorry. I have quick questions.
Yes.
In terms of talking about a downstream and the upstream, if the Linux is a legacy of everything else, I believe so. But how come the CentOS become the downstream?
No. Linux is a legacy of what you mean by what?
Like before the CentOS came out in the market, I think probably the Linux was the Red Hat is the one, like first one, right?
No. Red Hat is one of the company which is going to distribute Linux distributions, right? Like Fedora Linux is an example of Red Hat. Red Hat distribution, right? So there are two major subversions of Linux if you study it. Right? One is like this based, like what is the famous OS in Linux called?
Okay, so that means like whatever the release versions from the Linux Red Hat is going to distribute to the CentOS, and CentOS is gonna release it to the production and then to the end user, correct?
It's kind of little complicated. Say, yes, Ubuntu. I was talking about Ubuntu. It's a Debian-based Linux OS, right? So, and CentOS is based on basically CentOS is based on Red Hat and RHA, right? So the difference is there are two main streams of Linux distributions, right? One is Debian and non-Debian based. But why this CentOS is more stable? Because see, technically you cannot monetize open source distribution. Open source is available to anyone. But how this Red Hat monetizes, they'll give support to you people. If you have encountered any problem in the OS with respect to security or software upgrade or whatever, Red Hat will provide the support immediately. So that is where they are able to monetize. But since you cannot, single person cannot solely own a Linux distribution, right? Anyone can create a Linux distribution which is a downstream of the Red Hat Linux, right? Even a person who is authorized like you and me, we are able to do that. We can able to go and create a Linux distro which is going to be a downstream. When I say downstream, the same OS which is based on Linux distribution, Red Hat Linux distribution, but not chargeable, right? But same, everything is the same. Your security software update, everything is the same as RHEL, right? Red Hat Enterprise Linux. Right? So that is how they were able to do. CentOS was the more stable version of the same RHEL. Okay, and because you're getting my point, right? Why this is happening actually?
Yeah.
You can go ahead and choose another free version of OS like Ubuntu or Fedora or whatever. But the problem is, it is not as stable as RHEL, right? You're getting it, because RHEL is actively maintained by a community which is paid actually, right? So it is very, very active in security updates and software updates and all those things. Right? And since CentOS is based on RHEL, it's very, very easy for them to create a server with CentOS, and it's reliable basically. That's a basic point. Why OS has to be reliable in a server? Because see, server is going to serve some millions of data requests to the application. If a server is suddenly down, how bad we will feel. Right? Recently, they have improved the IRCTC website. I hope a few people would be able to remember the IRCTC before 5-10 years. How bad was that? You can literally never book a ticket in IRCTC at the peak time. Why? One of the reasons might be they might have not used the proper OS, right? Which is capable of handling all these requests and which is very reliable, which will not go down very easily. Right or no? Was I able to make sense actually? Yeah. Why we need a Linux OS? Why Linux OS is popular? And what's the CentOS? And all those things. And last year there was a major problem of this thing. I think you might be aware. The income tax portal was entirely given to Infosys, right? From the previously maintained servers, right? And there were so many problems last year. The data was not even, when people tried to log in, they were not even able to access the website itself. Why these things are happening? Any answers? What went wrong, even with a company like Infosys? What was the testing that was missed actually? Performance testing, load, yes. See, the problem is, right, there was a constant pressure to release this thing before the ITR filing for the particular year, right, last year. So obviously, as a testing community, we will know, right, as we keep on task is increasing, and at least I think 2 crore people, 2 to 3 crore people are actively filing income tax in last 2-3 years, I guess. Right? What if all the people, at least 10% of all these people logged into the application suddenly? Right? Maybe that application was accessible, maybe to 500 people, 600 people at a time. What if some 1 lakh people suddenly logged into that application? Right? Maybe not the problem with the OS, but the application itself, the server itself, server code itself was not able to handle all these requests, right, at a time. It has anything has a certain capacity in our real world. Server also has a certain capacity. So it was not able to handle all these requests parallelly at a time. So the server crashed. Right? So what was the remedy? We can do a load testing, but to improve the application, see, these are the simple things which we should have forecasted, right? And good companies do that. Companies like Amazon and Google do that actually, right? I don't know how many of you are working with AWS. Even AWS had 2-3 outages in the last 4-5 months, and that was a internet got cut in the meanwhile. Am I audible now?
And now, yes, you are audible, but you are paused like a few seconds.
Okay. My internet got cut temporarily. Okay. So, what was the solution to these kind of problems? To scale to the 1 lakh or 10 lakh people who are going to use the application at the time, what we should do? Any answers?
Then will be the cloud computing, right?
Yes, that's that cloud computing comes into picture. But what we should technically do? We should do something called scale up. There is something called horizontal scaling, right?
We're increasing the size or whatever. Yeah.
So there are 2 types of scaling, right, in the server end. As an API testers, don't think that I'm too much going out of context. As an API tester, we wanted to know all these terms to better understand things, to be able to better understand what is actually happening in the API. Okay. So there are 2 types of scaling which is going to happen in the server. One is called vertical scaling. Another is called horizontal scaling. So vertical scaling is, for example, a computer with, let's say, take the same configuration, 8 CPU, 16 GB of RAM, 500 GB of hard disk, might be able to handle, let's say, 500 requests per second. Okay. Yes, scaling is done using load balancer. We'll come to that right now. Right? So if I wanted to have 1,000 requests per second, right? Technically, what we can do? Can we double this configuration? 16 CPUs, 32 GB of RAM, 1 TB of hard disk. Can we do that or not?
I don't think so, because I think we need to go what is impacted, right? Probably CPU only, or maybe GB only, right?
No, anything. For example, let's say I'm increasing this 8-core CPU to 16-core CPU, and my request from 500 got to 1,000. Now I am able to handle 1,000 requests per second. Okay, it's technically possible, right?
Yeah,
but technically possible, but is it the right solution? How in a single computer, how much you can increase a resource? 16 CPUs, 32 CPUs. How much you can actually increase in a single computer? That's a hard limit, right?
It depends on what is the physical machine has a limitation of CPU, right?
See, even you have some 160 CPU cores, your voice also has to have a capability to handle all these cores, right? Even there's a physical limitation also. A single computer, you cannot put a 160 core. That's called supercomputer technically, right? You cannot just put X number of or infinite number of cores together and expect the computer to like linearly handle or linear scale according to your request, right? We cannot do that physically, right? You're getting my point.
Yeah.
Yes. And there is a limit to how much resource we can put in a single computer. Nowadays, due to the advancement in silicon technology, we are able to handle more number of CPUs and more number of RAMs. But again, we cannot just go on increasing the number, right? But what is the other solution? Instead of increasing this CPU core, what can be the other solution? This increasing the resource in the single computer is called vertical scaling, right? I can increase the CPU, I can increase the RAM, I can increase the hard disk, I can increase the IO ports in a single computer. That's the vertical scaling. So what's the horizontal scaling?
Add more servers, maybe.
Yes, simple. Right? I have one more server 2 or another. Let's in a simple term, computer 2, with let's say another 8 GB or 8 CPUs, another 16. Let's say here will put for difference from the GB of, and let's say 1 TB of hard disk, right? So it's another computer that is going to process some other request, right? For example, if 5,000 requests are coming per second, 500 requests can be given to this CPU, another 500 requests can be given to this computer for processing, right? Instead of increasing the resources, we are increasing the computers, right? So that process is called horizontal scaling. Horizontal scaling is technically feasible and it's a right solution, right? And this kind of splitting the request and giving to one computer to another computer, as someone was mentioning correctly, it is handled by a piece of software or a physical hardware combined together. We call that as a load balancer. So load balancer is responsible for splitting the request based on the load in individual computer and giving the subsequent request to the computers which is having the less load. It's a work of load balancer. Okay. Why this load balancer comes into picture? What is horizontal scaling and all those things we're able to, and what is this actual request we're able to imagine, right? Actually, right? These things are important to understand the API itself. Right? It's not like some tool that Postman or maybe the structure that we are going to learn. We are going to learn what is actually happening in the backdrop to be able to understand what these tools are actually doing in the front end, right?
Okay, so though, sorry, so load balancer will come in the picture because of a horizontal scaling, right?
Yes.
Okay, because there's a more servers, so to handle the machine. Okay.
So how this Infosys might have solved this problem? They might have simply added more servers and more load balancers to delegate all these requests to right servers, right?
Okay.
So horizontal scaling not only applies to your computer CPU or RAM, it also applies to your database. We'll come to the database shortly. So this load balancer, all these are connected. If you have studied the networking, right? All these are connected through your local IP networks and in certain configurations, certain topology like star or ring topology or whatever. These computers will be connected together, and the request will be delegated subsequently. So AWS is responsible for giving all these services to you. That's why cloud computing is necessary. Right? Someone was asking, is load balancer software? It's technically it's a software, but it's also making use of a hardware and your networking things to delegate the request to right servers. Right? We have a local LAN setup, right? Obviously, we would have studied what are the LAN networks and topology of LAN networks, right? And what is a subnet mask and how computers are connected via a local network. You would have studied all these things, right? So load balancer is a software which is going to take advantage of this network topology configuration, hardware configurations, and delegate the request accordingly. Hope that helps. Okay.
Quick question. In order to proceed this API, this course, do you have to have a cloud AWS knowledge completely?
Not necessarily. You just have to understand what is an AWS and how it is basically working. That's it. Basically means what? What it does actually. That's it.
Right.
We don't have to have a knowledge of AWS.
Yeah, just so I want to make sure that I know some basic knowledge about public, private network, public network, creating this. Okay.
And networking itself is a very huge concept. Okay. And even I am not expert in those skills and all, but I know what is actually happening.
Hope so. I can handle this thing. Thank you.
Anyway, we don't have to have a AWS knowledge. I just want you people to understand what is an AWS and the things are typically happening, general things that are happening around AWS. So Kavita was asking how you define a cloud computing. Basically, cloud computing, as I was saying, is tens and thousands of computers that are connected together, and the splitting of these resources from the computers handled by this software called hypervisor. And whenever we need some resources in a particular configuration, we will get those resources through this hypervisor software on demand. So cloud computing is responsible for providing physical computer configurations and services that are needed to put some server side data into the remote end computer. Okay? That's how I define a cloud computing. So basically, whatever we saw is all these services are example of a cloud computing. Load balancer example of a services in the cloud computing. Okay? Difference between horizontal and vertical scaling, as I was just saying previously, right? Vertical scaling is you're increasing your computer resources, increasing your RAM, increasing your CPU cores, or increasing your hard disk. As horizontal scaling is adding one more computer with some configurations together, so that we can increase the computer capacity as well, but we don't have to vertically scale the computers as well. See, hypervisor is responsible for only splitting the configurations for you, right? How much computer you want, how much resources you want, but to which computer which request has to go, that has to be decided in some point, right? That deciding point is called load balancer. Right? Computer configurations is given by hypervisor. To which computer this request goes is decided by the hypervisor. Sorry, a load balancer. Right?
Yeah, quick question about the hypervisor. Isn't it the hypervisor is taking the resource from the physical machine, or?
Yes, it's a physical. It's going to get the resource from the physical machine.
Okay, great. Thanks.
To put it into a perspective, let's say I have two computers. Okay, one computers have 8 GB of RAM. Okay, and let's say 4-core CPU. This is a configuration of a computer one. We call this a C1. And let's say I have another computer called C2, which is having 4 GB of RAM. Okay, and it's having 2-core CPU. Possible, right? And these two computers are connected via cloud computing networks, right? But as a user, I am having one configuration. Okay, I want some let's say 10 GB of RAM. Okay, and I want some CPU with 5 cores. Is this possible? No.
But I think it's not possible, because is it possible? I guess you have two different computers and you're trying to get this 10 GB RAM and 5 cores. So you need to, I don't think so.
Okay, it is possible actually. That is the work of hypervisor actually, right? So you don't have to treat this as a computer one, computer two. These are, see, RAM is what? Again, a physical chip that you are going to insert into some other board, right? CPU is what? Again, a physical CPU with a certain number of cores, right? But what is the purpose of this hypervisor is, where this hypervisor comes into picture is, right? It's going to take 8 GB of RAM from this computer. It's going to take a 2 GB of RAM from this computer and present as a single 10 GB of RAM to the user. Similarly, it's going to take 2-core CPUs from this computer and 3-core CPU from this computer and present together as a 5-core CPU to the user. These are physical real thing that real physical configurations of a computer, but these are virtual RAM and virtual CPU, VRAM.
Okay, so that means you completely consume all the resources. Okay.
After completely consuming, also we will still be left with 1-core CPU resource which is not used.
Okay.
You're getting my point, and it can be allocated later to another user.
Makes sense. It's clear. Thank you. Yeah.
That's a purpose of this hypervisor. Now we are able to understand the hypervisor's thing, right? It's going to take this physical resource and convert into a virtual resource, and by splitting into some configuration which it thinks it's optimal, and give it to the user. right?
Yeah, thanks.
Now, load balancer work is what? To delegate the request that is coming from your client to this computer, virtual computer. Right? That's the purpose of the load balancer. If there are another computer like this, it's going to decide to which computer the request has to go to. Okay. So, in the backdrop of an API, all these things are happening without our knowledge, right? And all these things are happening within a matter of milliseconds. That's the beauty of cloud computing or internet itself. So, we are understanding like cloud and what is a server and all those things, right? See, a server again, it's a machine with some RAM and CPUs. RAM generally in the cloud computing environment, all these things are virtual RAM, virtual CPUs. When I say virtual, it's hypervisor is taking a physical resource, converting it to a virtual resource for you and powering you. Right? And we also talked about OS. There has to be some OS that has to sit on top of this computer so that that is going to handle the request. That OS we saw, right, is typically Linux-based OS, and generally CentOS or Rocky Linux. If you go to Amazon AWS Center, we have a distribution called AWS Amazon Linux, right? We have all those things. OS part is done. But inside the OS, there has to be some software that is able to understand the request and process the request, right? I don't know. OS purpose is what? Providing a platform to install that software. But what is the actual software that is going to handle all the requests? Any examples that you might give? Any examples you can think of? So that software or library or piece of code, my question is, what is that software or library or tool or the piece of code which is going to run on top of this OS and that is going to handle your request? Any answers? Yes, it's an API, correct? But that API has to be written in some library, right? Any library that you can think of. In Java, what is a famous API creation or server creation library? Apache POI, no. See, Apache POI is a library, right? But if you put it into a server, that request to access this Apache POI library has to be read from some application, and that application has to process all these requests, right? Rest assured, no. See, I'll give you some examples. So those applications can be created using this tool or server-side libraries. In Java, very famous thing is called Spring MVC or Spring Boot. Even heard of this term? In a very raw term, we call that as a Java servlet. Java servlet is a piece of code which is going to read your API request and process the information, right? But there are some libraries which are better suited to write this Java servlet and write this API code so that the API is able to process this information, right? So that library is called Spring MVC and Spring Boot in Java. In Node, we can write a server using Node.js, right? And what are the other examples? In Python, we have Spring is a Java framework. Yes. And Python, we have frameworks like Django, Flask, right? In Ruby, we have a framework called Ruby on Rails. Okay. So what are the purposes of these framework or library? This library are used to create an API, right? You can write code to create an API, write an API, and that API is going to run, and that API is going to be responsible for reading the request from your client. Right? Yes, framework is just to make our work easy. What is that work? That work is to create a server-side API application. Right? And Spring MVC is a framework. Node.js is actually a raw programming language, which inherently has server side code built into it, right? So generally, you can consider the Spring Boot or Node.js and Django Flask and Ruby, and all these libraries are used to create an API in the server. So when I'm talking all this time, going to process the request. But what is that request actually? Right? Client is going to trigger a request. This server-side code, which is written in Spring or Node.js or Django or Flask, is going to process that code and going to return the response. But what is the request is actually consisting of? What is this request actually? Any answers? This request we call as a what request? Any answers? In a typical Java world, we call as a HTTP request. Right? So client is responsible for triggering this HTTP request, and the server is responsible for reading this HTTP request and giving the right kind of information to the client. But my question is HTTP only one kind of request you can do over the internet? Yes, HTTP is also one kind of request, but it's very, very famous to handle your web-based request, right? And there is also a request called FTP. Right? Not only FTP, there are many protocols like that. Right? TCP/IP, FTP, HTTP. Right? These are the protocols or set of standards that are defined so that the request that you are triggering should be in the right format, so that the server can understand what type of request is this. Right? So coming back to our Google example, if I go to google.com, right, anyone have explored this network tab in the browser, Chrome developer tools? FTP is a file transfer protocol. If you have any FTP server hosted in your like a server, right, which is going to store your files, images, or videos, or whatever, you can access those files by using this FTP. We'll talk about this FTP little later. But coming to the HTTP request now. So my point is, HTTP is not the only request. That's the thing you should understand. It's one of the type of the request. Okay? That is the only thing I want you to understand first. Okay? Now, if I hit the google.co.in, have anyone explored this network tab in the Chrome window? No. So if no, please go and explore. Whatever API request that is being triggered to the server, right? You can monitor everything in this network. Okay, before coming to network, what's the purpose of this elements tab? You will definitely seen in some Selenium course and I guess.
Yes, to find this the web elements value.
Yes, every web element in this page is okay. Is loaded as a form of a DOM, document object model format, right?
Yeah.
Yeah, and to locate the element and find its attributes. What's this console then?
Console is you want to find out customize a web element maybe from the DOM.
Yes, one of the purposes of console, but generally, what's the console? Console is any area which is going to execute your JavaScript code. Give any JavaScript code here, it's going to execute. And it's going to, it's going to show some result also. Like, for example, if some front-end library is running and it's not, it's going to log something or it's going to throw some error, everything you can view in this console area. Okay. Let's say, how many of you are aware of this JavaScript pop-ups, alerts? Yes. See, when I execute a JavaScript code like this, alert is just a method in the JavaScript. If I trigger that method, one pop-up will appear like this, same. Some message, whatever we give inside this alert box. Right? So I'm executing JavaScript code here inside the control. Actual JavaScript is executed right here. So this console is actually going to execute any JavaScript code that you're going to give here. Okay? And console is also responsible for doing many things over your document. So you can find any DOM elements using this many methods that are available. Okay. So you can explore this actually. Like not necessarily for this course, but if you are interested, you can explore this document. Document is the object that is given by JavaScript to access the document object model and do some operations over it. Okay. Just explore this; it's very useful, especially if you are interested in Selenium. Okay, so we'll come to this record a little later. Right, but record is kind of a new functionality that's given by Chrome. As you can see here, right? It's going to record the user activity inside this particular website. But and we'll see two more main things before moving to the other small tabs. What is the sources tab? Any example? Any area? Sources tab is going to load all your HTML, JS, and image files, right? And you can see all this here. Okay, go to images. See that Google, this image is coming from this API request and stored in the sources tab. Okay. You can see all these things, right? Where these images are coming from. So those things you can view in the sources tab. So finally, what's the network tab? What's the network tab? It's going to, you can see all the API requests that are triggered from this application. So I'm just going to hit the google.co.in. So what is triggered? See, so many APIs are triggered, right? But our interest is this API, right? You see here, this is the URL that is triggered, http google.co.in. And this is a get method. Any request has some HTTP method that are associated to that, right? Get, post, put. We'll see the difference between those. But get is typically what? We'll mention request method as get in scenarios where we need to get the data from the server, right? Right or not? In this example, what data we are getting from the server? What data we are getting from the server? Yes, the page and its content, right? And what is this status code? 200 indicates success, right? We'll see in what is the status code a little in depth later, but 200 indicates success, right? And there is something called request headers, right? Any HTTP request will contain what? This is the URL or endpoint. And what type of method is that? Either it's a get request or put request or put. Here it's a get request. And there is something called request header, right? In every request, you can see this. What's the purpose of a request header? To put some additional information regarding what type of request is this, right? In headers only, we'll put the key information, and we'll put the method information, right? And we'll also put other basic information which can be read by a load balancer or basic code that is going to read the request, so that it knows what type of request is this and where to delegate this request correspondingly to, right? And any authentication or authorization information. Simply, an API can be authenticated, right? You can put your own authentication mechanism in place so that unauthenticated users cannot use your API, right? That is also possible. All the authentications you can put in your header information. So header is a kind of key information. It's kind of, let's say if you're writing a post, right, to someone or email to someone, header is important. Subject is very, very important, right? Why a subject in email is very, very important. Subject gives a gist about what that actual content is about, right? Right or not? Similarly, in a HTTP request, header is very, very important and it's mandatory. It's give a gist about what type of information is that, whether this information is right or not right, coming from right source or not, authorized or not. Everything you can get from the header information, right? So a typical HTTP request will contain what? Will contain what? Will contain a URL or endpoint. Endpoint is nothing but a URL when we come towards an endpoint in shortly, right? URL endpoint information it will have. In this example, what's the URL endpoint information? This one, right? And what are the other things it will have? We have some more talking. It's very noisy, I guess. Can you please go on mute? Thanks. So it will have URL information, and it will have the request method type, whether it's a get request or put request or put. In this example, it's a get request, right? And it will have a request. What it will have? Request header. Right? Someone was in the answer correctly. It will have a request header, and what else it will have? Status will come from the response, and what else it will have? It will contain an optional request body. Just a minute, I'm getting a call actually. Hey, sorry, just got a call. Okay, coming back. So there's something called request body, which is optional. Okay. And yes, the request parameters will come to that. Request parameters can be part of the URL information as well. Right? Okay. And there is this request body information, right? So why we need a request body? In this is a get request, right? Do we have a request body here? No. So why we don't need a request body in a get request? Because typically request body is used to post the information to the server, right? Here what we are doing, we are just getting the information from the server, right or not? Yes. So in a get request, we don't have a request body, right? And what are the other requests which we need a request body? In a post request, in a put request, right? Why we need a request body in post and put request actually? Yes, in post request, we are going to create some data in the server. In put request, we'll create or modify some data. So we need a request body. So request body is something which is going to, which is information which is coming from the client, in this example from a browser. And that information is going to be posted to server. That information has to be given in a certain area in the request, right? That area is called request body. So if I search something, then there will be a request body. It's a very tricky and complex question. I'll come to that a little later in this session, right? It's a little tricky. Technically, you can do, yes. to give a straightforward answer, yes, but how, we'll see a little later. Okay. So yes, so typically in a put, post, or a patch request, we have a request body. Okay. Now, what are the, someone was saying query parameters. Yes, query parameters we can put. So this is a part of a API request, right? We will have a endpoint, query parameters, method type, headers, and request body. Right? And path parameter, query parameter, everything will come as a part of this endpoint. We'll discuss all this. Yes, you are correct. Technically, you are correct. Okay. Now we'll talk about request body in a little detail. Yes, we'll see all those examples. It's little early. We'll see the concepts and then we'll see the examples. Okay. So, what can be the format through which the request body can be sent? Key value pair, yes. What is that format called? Yes, it's called a JSON format. Okay. XML format, yes, we can send XML. And other formats, text, yes, we can text, send a text data. Yes. Then any HTML, yes. Like I think many of you are already aware of all these things. What are the other formats that you can send in the request body? There's something called form data, right? Python, no. And what are the other types of data? Can we send an image? Can you send an image or video? Yes. These are technically called binary files, right? We can send an image or video. Right. So all these things can be sent via your request body. But what is the famous one among these items? JSON format, yes. Now, since XML format is kind of little clunky and GraphQL, yes. GraphQL also. Little clunky, it becomes little clunky, right? XML format. And JSON format is most widely preferred because any answers. JSON is the most preferred data format for communication. It is preferred most widely, any answers. Lightweight, yes, one of the reason. There is another important reason to that. Any answers? Key-value pairs, it's okay. That's how the JSON is structured. But what is the main reason behind using a JSON? Yours is a full form of JSON. Yes, technical answer is correct. JavaScript can process without changing its format. JSON is what? JavaScript object notation, right? JSON itself is a thing that came from JavaScript world. Right? Since most of the client like browser or your like Postman, all these things are, even your applications, mobile apps are using JavaScript, right? It's very, very easy. If we send this data over JSON without even processing, you can directly read the data through JavaScript. Okay? That's the main reason. JSON is native to JS. That's a very, very important reason why JSON is adapted. Right? Someone was answering Python, but why we can't send a raw Python or Java code via an API, via request body? Why it's not possible? Not heavyweight. No. What's the reason? See, JSON is a common data structure, right? It can, it's a standard that is established by the community, the developer community, right? But if you write a Java or Python code, what is the situation? The other party also has a Java code or Python code, respectively, right? If you write a Java code, then there should be a Java kind of library in server end to read your Java object, right? What if that server has Python server, right? Like Django class, it will not be able to read, right? So it's kind of a common communication mechanism among the servers or through the internet, through which the data has to be communicated. There has to be some common means of data representation, right? For different languages to be able to understand the same data structure. Right? That same common medium of data structure is called a JSON. Right or not? So that's the reason we cannot send Java or Python code via an API. That part will not be able to understand. So only it's not supported also through HTTP. This data processing is faster as well, and someone also handled it, like said it very correctly. Easily convertible to object at server side. That converting to object is called serialization deserialization process. Yes, servers are designed to understand the JSON format. So any data can technically understand the JSON. Any server can understand. So now we are able to bridge a path, right, between what is happening in a client-server architecture. Yes, platform independent. That's basically the point. So there is a client, okay, which triggers an API request. And that API request is in the what format? It's in HTTP request format, typically. And this HTTP request contain all these information, right? And this HTTP request will travel via internet through what? Physical fiber optic cables, and it will come to this load balancer. It will not directly come to the server. It will come to the load balancer, right? And this load balancer is responsible for redirecting the request to the right server. Okay, and server reads the information and return the data back to the client. This is the flow, right? Right or not? So one question is, we are hitting google.com here. How it knows that it has to go to the Google servers? What is actually happening there? Through IP address. There is something called DNS server, right? DNS resolves the IP address, and every IP address is mapped to a particular server. These are taken care by international standards, right? And that IP address is routed through something called internet gateway to the right server sitting in the right location, right? And that server that IP address is not typically directly a server IP address. It's actually a load balancer, right? Which comes into the picture. It's actually forwarding all this IP, this request to IP address of the load balancer, and the load balancer delegates the request to the server, and the reverse process happens, right? So DNS comes into picture in this example, right? Now, the server has to read the information from somewhere to get return the data, right? See, I'm loading the google.com here. What is this portion? This is actually image, right? This is actually an image, right? I'm not asking what's the difference between DNS and load balancer. See, DNS is again a terminology. It's a technically there are many things that are happening, right? DNS is actually a kind of a DNS server is actually kind of thing that is provided by your internet service provider or your domain host provider, right? Wherever you have purchased your domain and all those things, and they have certain set of IP addresses that they can give it to you to match across your domain names. You can purchase your domain names there, right? And they are responsible for resolving all your DNS and all those things. And your internet service provider will catch all this information so that it second time it doesn't have to hit this DNS server to find the IP address and all those things. Right? DNS and load balancers are totally different terminology. Right? Okay. See, this is an image, right? And this is actually a HTML element, this search box. Again, these are HTML elements, these are links. Actually, right? And there are certain Javas, if you go to this, there are certain JavaScript code that might be loaded for this to execute, right? This is a JavaScript code, right? To be able to do some operation over this particular web page. But
I have a doubt one. Okay, talking about the Google servers, how Google servers, find out when the request comes from outside. So say DNS will solve the problem. So is it happens in all the other browser or other web page? Same thing happens. Like only DNS is gonna help.
What do you mean by other? No. What do you mean by other things? It will happen on.
Like is it solved by DNS or any other approach comes in the picture? Like in terms of talking about when we hit the request to the Google,
it is actually resolved by DNS only. Okay, you can consider DNS as an individual independent server that is having kind of a mapping mechanism between your website address and your IP address, right? And it will resolve because, for example, there's a website called godaddy.com. You can purchase your domain there. In AWS, you can purchase the domain there. And these domains are owned by these domain service providers, domain name providers, right? For example, if certain domains are owned by GoDaddy, you cannot purchase the same domain from another provider, right? And they own these domain names, and they will allocate a particular IP address once that is available and map to the domain name if that is purchased. Okay, and these mappings are maintained in the international database, international DNS databases, which are consistently and uniquely maintained with appropriate communication between individual DNS servers, right? Which are maintained by the main DNS providers. Okay. And once the DNS is resolved, every time DNS doesn't have to resolve in a DNS server only. Your internet service provider will be there, right? They have caching mechanism to be able to cache the important URLs, frequently hitted URLs, and catch their IP address there itself. Even your browser catches your certain IPs which are frequently used, URLs which are frequently used. So that this website is kind of dedicated to write IP address. Once this IP address is resolved, then it's a matter of your internet and your WAN, right? Your network topology to redirect this particular thing to be able to redirect this IP to write like servers. If you hit any IP address, right, we have servers, for example. Just ping google.com here. Okay. It's coming from this IP address, right? Let's copy this IP address. Okay. So if we do this, it will go to google.com only. So alternately, we have one service running here. I will show something. See, this IP address resolves to, for example, when a particular server is trying to resolve an IP address, it knows where to redirect. Right? Any IP address will be, there will be certain unique set of IP address that are prefix which are assigned to certain countries. Here in this case, it's a United States, right? Right. So it will know this IP address and internet gateway that are acting as a network in the backdrop will know where to redirect all these requests, right? Based on this IP address, right? And it will hit the right servers which are present there. Right? For example, servers is not present anywhere. These DNS will propagate. For example, let's say you are buying on website, right? Google.com. Let's say you own Google.com, right? And you have that mapping, this IP address called 142.168 as your mapping to your DNS, right? This DNS address propagates throughout the world. Right? You can see the mapping also. See, when I hit google.com, see where and all propagated. These are the important locations where the servers are actually present, right? Typically in India, it will be in Mumbai, and a few servers are in Bangalore, right? So this IP address is resolved throughout the world, right? This Google, since it's present throughout the world, google.com is very, very famous. It's resolved throughout the world, right? So this is how servers in different locations knows this IP address belongs to google.com only and it's not resolved to any other address. Wherever you hit, it will, your content will be localized based on the location, but the google.com will be only loaded because this IP address is present throughout the world. Okay? This is a kind of a little complicated topic. Maybe you can explain a little more on that.
No, I got it. Thanks.
Okay. So now this since this IP google.com is present in the Mumbai servers also, okay, this IP address is resolved in the Mumbai address also. This data that you are seeing is actually cached in the Mumbai servers. It's not coming from the US. Okay, it's actually coming from the servers in Mumbai and it is given to you. Okay. Since the data is also propagated here and since google.com is most frequently hit, it will be okay. See, DNS is a very huge topic, not a part of this curriculum also. I'm just trying to make you understand like the concepts of an API, what is happening in the backup. It's actually more related to like your networking, right? DNS and all those things. Okay. The session will be automatically uploaded. It's already being recorded actually. The recorded link will be shared to you by Rahul. So we'll see like one or two more concepts before wrapping up the session today. Right? So now we know the server reaches these, the request reaches the Google servers and it will go to the load balancer, and from the load balancer, it will go to the appropriate servers and return the data. To mail ID, I'm not sure. There's a WhatsApp group. If you are there, I think the links will be shared there. Basically, for your session recording, you can contact her. If you're not there in WhatsApp, you can ask him to add you in the WhatsApp. Or if you wanted to forward it to your mail ID, you can ask Rahul as well. You have his email ID or contact number, right? You can contact him directly. That is how you have enrolled, right? Actually, through Gate Automation. Okay. Now, one final question is, now we know this thing, client, it will trigger a request that website will be resolved to DNS IP address, and the request will be transferred to via internet to load balancer and from load balancer to server. But the server has to get some data from somewhere to return to the client, right? So where it is getting the data from? Any answers? Server cannot itself, in the hard disk of the server itself, it cannot store all the data. Where the server is getting the data from? This API from the server is going to process the data and return in a certain format, for example, JSON. But it has to get the data from somewhere, right? To be able to return the data. Yes, as answer. It gets the data from database. You cannot simply store everything in a server itself, right? And what are these databases? What kind of databases you might be aware of? SQL databases like MySQL, Oracle SQL, DB2, MS SQL, Postgre, yes. These are SQL databases. And there are no SQL databases also, right? Right? Someone has answered, I guess, H2, Mongo, MongoDB, and many other examples. Cassandra is my favorite database. Cassandra. There's something called Redis, which is also kind of database. Redis. Any other examples of NoSQL database? There's one more famous database, which is also one of my favorite. Is called. How many of you heard this term called Elasticsearch? It's a database. Anyone heard of this?
Is it Kafka, Elasticsearch?
Kafka is not a database.
Okay.
It's a streaming and queuing mechanism actually.
Yeah, I heard from there some Elasticsearch or something like that.
Elasticsearch is a database. Kafka is. So these are the NoSQL databases examples. So server is responsible for reading the request and getting the data from the database, either in the SQL or NoSQL database, and return the data back to the client. Right?
So Karthik, one question. So I know database is server, but also we can see all the application server as well, right?
Sorry?
Application server.
These application servers are called these things. Spring, Node.js, Django, Flask, Ruby on Rails.
Okay.
See, in this, when I talk about this load balancer, redirect this data to the server, right? The server is actually split into two parts. One is like this app server, and another one is called web server. Okay, this app server response. This server is actually split into two parts. These app servers are called Spring, Node.js, Django, Flask, Ruby on Rails. What's the example of a web server?
Can we say like a Chrome browser or a Firefox browser or the web server? No, right?
See, these are clients, right? These are not servers.
They're clients, yeah. Sorry, yeah. So this maybe Apache server or something.
In Apache, what server is very famous for Java?
Yeah.
Tomcat, yes. Okay, Tomcat. And what are the other servers that you might be? Which servers are examples? Any other examples? There's one more famous web server called Nginx. Anyone heard of this?
Yeah, Nginx. Yeah.
So any request that is coming from your load balancer, right? Which first will enter the web server only. Okay. This web server will delegate the request to the app server. Okay. So the web service reading is used for reading the HTTP request, whereas this app server is used for processing the data. The server is split into web server and app server. Okay. This is used for reading and redirection. This is used for actually processing the data. Right?
Yep. Got it.
Okay. So it is web server, app server, two different things, but acts as a single entity to be able to process your data. Right? You can say app server is contained within a web server. Your web server has all the data. For example, to put into a perspective, this web server we talked about Tomcat, right? Okay. And Tomcat has a folder called web apps folder. How many of you have known? It's a very famous name, right? This web apps folder is going to contain all your API code, your server code, your app server code. And this Tomcat is going to be responsible for hosting this application server inside this web server. Right? So app server is contained within a web server. So only a request comes to web server and it's delegated to the app server subsequently. Right?
Okay.
Nginx is a very general purpose thing. It can access a web server for Java also, and it can redirect a request to a particular port. See, to HTTP requests are read from a typical port, right? Port of your computer, and HTTP request is read from port number called 80 typically. So HTTPS is read from port called 443. Okay. So this Tomcat is going to constantly monitor these two ports for the HTTP and HTTPS request. If one request is coming from the particular port, it's going to redirect your request to your app server, and that app server is responsible for reading the database and put it into a proper format like JSON and return it back to the web server, from web server back to the load balancer via internet, via this fiber optic cables and whatever, and via to your computer browser called the client. Right? So this is how client server architecture works. I'll stop with this today. Someone was asking the syllabus, right? Just give me search and share it back to you. So you're able to see the screen actually. So this is the course contents that we are going to plan for. Right? We talk about introduction to API and the API course generally. We'll also continue the same, and we'll see about REST frameworks, HTTP methods, and its examples. Right? So once we get hold of this API, theoretically, we'll go to the Postman and the features inside the Postmans like collections and scripts, and the Newman, which is a client interface, like terminal interface for a Postman, which all those things. And we will next we'll go to the REST Assured. Same thing, whatever we did in a Postman, how we can be able to do via REST Assured library. We'll see what's the serialization, deserialization, and POJOs, and the application of Jackson in this context, and like parsing and assertions and all those things. And to create an entire API framework as such, we'll use Cucumber. We'll see about what's a Cucumber and this analysis. We'll be seeing how to create a basic framework with Cucumber along with integrating this API testing Rest Assured, right? And we'll see about reporting and generally how we can create an API kind of suite, automation suite. So this is a scope for this course.
Karthik, hi.
Yeah.
I just wanted to ask a question here is like we discussed two servers, one was Tomcat and there was Nginx.
Mhm.
Tomcat, I think, is commonly known for a Java application. What is
Yes.
Nginx used for?
No, Nginx is similar to Tomcat, but one more additional main what they use for Nginx is like if the request is coming from certain endpoints or certain headers, you can easily redirect the same request to certain other ports using Nginx. Doing configurations is redirections very easy in Nginx. Just a JSON kind of configurations you can create and you can do all the redirections via Nginx. A little technically it's also possible in Tomcat, but a little complex. You can there are a lot of XML files you want to configure it. That is very easy in Nginx. Both are actually same. Technically, both are actually app servers. Sorry, web servers, which are going to do the same job.
So Tomcat is provided by Apache. Who is providing Nginx?
Nginx. I think Nginx. Some people. I think it's also open source, and there's also some paid version. I guess.
Nginx itself is a company.
Yes.
Okay, so it has much more
Nginx
functionality than Tomcat.
It's not like more functionality and all. See, both the purpose are same, but Nginx is kind of use case is different. If you want to host a simple application that comes a bundle along with Spring, then Tomcat is more than sufficient. If you have 2-3 applications running in different application servers, like for example, one's running in Java, one running in Python, one running in Node.js in different ports, then you have to use Nginx to redirect all these requests to subsequent ports. A little use case is different, that's it. But concept is the same, both are web servers.
Okay, thanks.
See, I know like initially it will be very confusing, these terminologies, but I think once we go through the course and like see what is actually happening in API, right, I think we'll get hold of it. Timing will be 6 to 8 only. Same timing for the weekend, Saturdays and Sundays, 6 to 8, I guess. So yes, Sunday also. So any other question with respect to whatever we saw in syllabus and all those things. Fee structure and all you can talk with Rahul. I'm not handling the fee related things. So we'll meet in the same time tomorrow, 6 p.m. IST, right, to continue the same session.
Karthik, one quick question.
Uh-huh.
So when we do the API testings, are you providing us the core or like because I didn't find any kind of like very stable page to test for the API testing purpose?
No, I didn't quite get the question.
Like, are you providing the API and when we test it, you probably give us an assignment and when we test it.
Yes, so what it's not kind of an assignment kind of thing. We will use some APIs provided by some weather examples, weather.com example. Right? We'll use those API, we'll use some other APIs which are open source and provided. But what I expect is to like whatever we do in the class, I also expect you to go and do the same on your class and explore different things.
Yeah, I mean, I really like what I try to understand is what is happening in the real-time work that we do this almost similar type of things. And if we get like a reliable source, like real, you say the whether API, whether something's a page, web page is which can provide the API code so we can test it, right?
Yes. We are going to take a weather API as an example, given by Open Weather Map company, right? We are going to use that API mainly throughout this course to test and draw parallels between real-time projects. That's what we are actually using.
Okay. Great, thanks.
One of us do we need to know Java for Rest Assured? Yes, little bit of Java understanding would be helpful.
For Java, core Java is enough, right? To understand.
Yes. For Java.
Okay. Right.
Selenium, no need of Selenium to understand this. Selenium is like before you automation type of different. Don't need to know Selenium. Any other questions? Python, no, Python is not in the scope of the course. I hope this session was useful. So we'll continue the same thing tomorrow, right? And throughout the course as well. Video is already recorded, like subsequently uploaded to the cloud as and then. So the recording will be available shortly. The link alone you can ask for.
So lifetime member, I can access right now this video. This
In half an hour time.
Oh, okay, half an hour. Okay. All right, sure. Thanks.
So I'm closing the session.